This is exam 3 review. So maybe we'll do like 10 to 20 questions for the first video. The first one is saying find the domain of the function in the interval notation. So how do we find the domain of this rational function? We see the denominator cannot be 0. We write down as x plus 17 cannot be 0, not equal to 0. So which means x not equal to negative 17. But we want to write in interval notation. So write as this. I cannot click on this answering button. Let me see if I can go back to, no, I'm not able to. Okay, so I write in an interval notation from negative infinity up to this number, negative 17. Close parentheses. Now use union, open parentheses, start from negative 17 up to past infinity. If you want to have a picture in your head, you can think about the real number system. Where 0 sits in the middle, this is called real number line. Go towards the right, goes to past infinity. Towards the left, that's negative infinity. 0 sits in the middle. So x cannot be negative 17. Let's see negative 17 is here. Is on the left of 0. Left numbers on the left of 0. So cannot be negative 17, open circle, right? So all those numbers smaller than negative 17 or all the numbers bigger than negative 17 works. Only negative 17 does not work. So this splits into two intervals, right? One goes down from negative infinity. We will always count number from smaller one to, you see, it goes from negative infinity. So it goes from left and right, basically, when we're counting numbers. So it goes from negative infinity up to this number, negative 17. That's this interval. Then the upper interval starting from negative 17 goes to past infinity. So that's why we write in this case. I hope this makes sense for you. If it doesn't, you can ask me questions in class. Let's see, second question. Second one, we have f function as a rational function, g function as a rational function. So we want to subtract in those two functions, then simplify. So subtract those two fractions. Let me just write like this. So this is subtraction sign. I'm subtracting those two functions. I need a common denominator. So I'm thinking x squared minus 6x, the second denominator can be factored as x minus 2 times x minus 4. Right? Because negative 2 times negative 4 gives me positive 8. And negative 2 plus negative 4 gives me negative 6. So I know this one can be factored as this. So the first one already have x minus 4. So f already have x minus 4 as a denominator. So I need to multiply by 1. And this 1 is x minus 2 times itself. So I need to multiply by x minus 2 over x minus 2. Because x minus 2 over x minus 2 is just 1. Anything multiplied by 1, the value stays the same. So once I do this, I have a common denominator. But then I have to multiply those two binomials. Right? Multiply that two binomials, what I get? I get x times x, x squared. I get x times 2x, I get negative 2x. Then 4 times x, I get 4x. Then 4 times negative 2, I get negative 8. So the numerator, this numerator, when I multiply, so these two, when I multiply, I get this. So I can simplify those two. Those two are like terms. So I get x squared, those two simplified to be 2x. So I have x squared plus 2x plus 8 in the numerator. Now, I need a minus 9x minus 20 from this. 9x minus 20, that's the numerator of g of x. I have the same denominator, okay, the denominator just this, or just this. This is the denominator. Okay, I'm not going to write it. That's the denominator. I have two binomials. So let's subtract this. I have 2x minus 9x. So that becomes negative 7x. I have negative a minus negative 20. That becomes negative a plus 20. That becomes plus 12. Okay. So the numerator, I have x squared minus 7x plus 12. The denominator, I have x minus 2, x minus 4. Maybe I can simplify that. Let me say it better one more time. So the numerator now, I have x squared minus 7x plus 12. And the denominator, we have x minus 2 times x minus 4. So f minus g, I have this now. The numerator, I see, I can factor. Do you see the numerator? I can factor as x minus 3 and x minus 4. Okay, because negative 3 times negative 4, that's positive 12. Negative 3 plus negative 4, that's negative 7. Then I have a common factors in the numerator and in the denominator, which is x minus 4 in the numerator, x minus 4 in the denominator. They cancel out. So I'm left, the answer is x minus 3 over x minus 2. So now asking, the domain of the difference function is x not equal to 2, right? Because x minus 2 not equal to 0. That means x not equal to 2. So I write it in interval notation. Oh, this one I can write it in this. So x not equal to 2, just write it 2 here, okay? This is called a set notation. So this one is called a set notation. So x bar, x not equal to 2. Let's see 3. 3, we want to find the domain of this rational function, right? We do the same. You see 2x plus 3 not equal to 0. Right? Not equal to, I have a slash through this equal sign, not equal to. So we solve this, that means x not equal to negative 3 over 2. X not equal to negative 3 over 2. So writing in the interval notation, I write a negative infinity, open parentheses, negative infinity. Have to use this up to this number, negative 3 over 2. Parentheses, close parentheses, union negative 3 over 2 up to positive infinity. Okay, use this interval notation to omit the number negative 3 over 2. Or we want to find the domain of, let me get my pencil first. Domain of this rational function. So the x not equal to 7. So that's this one. Five, find the domain of this function. We want to factor the denominator, right? See when the denominator will be 0. So we see we can factor as x plus 3 and x minus 1, right? Not equal to 0. So that means x not equal to 3 and x not equal to 1. Select the sign and then enter the values. X, well, I cannot see, I cannot click on it. Just x not equal to, right, right like this. X, so you choose a sign not equal to -3, comma, 1, right? Six, we want to multiply those two fractions. So when we multiply, let me just change this to be multiplication, okay? I want to multiply those two fractions. So we need to put in a factored form. So the numerator of f can be factored as x minus 1 times x minus 4, right? Multiply g, the numerator of g can be factored as x minus 3 and x minus 5. Okay, so when we multiply f with g, the numerator will have 4 factors. And the denominator, let's see how we factor that. X squared minus 6x plus 5, that's x minus 1 times x minus 5. Then the denominator of g, it can be factored as x minus 2 times x minus 4. Okay, I hope you see the patterns, how I factor this. Okay, you see, let's see the first one. This is positive 4. This is a -5. The middle term, the coefficient is -5. So I'm thinking 2 factors of 4 has to be negative, adds up to be -5. So there can only be -1 and -4. Because -1 times -4 is positive 4. -1 plus -4, that's -5. Well, let's see this one. I have 15, 2 factors of 15 multiplied to be 15, adds to be -8. So there has to be -3 and -5. -3 times -5, positive 15. -3 plus -5, that's -8. Same thing for the denominators. Now we have this factored form. All we have to do is to find the common factors in the numerator and in the denominator. Because something divides itself becomes 1. Then we see x minus 4 in the numerator, x minus 4 in the denominator. These two becomes 1. We have x minus 5 in the numerator, x minus 5, and these two becomes 1. Something divides itself, becomes 1. So what's left? 1 times 1 times 1 times x minus 3 in the numerator. Denominator, I have x minus 2. So that just becomes x minus 3 divided by x minus 2. So the second part is that the value of x that need to be excluded from the domain of the product x. So basically this means which value is not in the domain, or 2, right? So this part you put 2. 2 is not in the domain. This is 7. Maybe this video will do 10 questions. 7, we want to multiply those two rational expressions. Again, we're looking for common factors in the numerator and in the denominator. So this is the difference of 2 squares. So let's write it down on the side. That's y minus 4 times y plus 4. And then multiply by y. So the denominator we have, let me write in different colors for denominators. Denominators, the first one we can factor out y. y times y minus 4. Right? Y squared minus 4y has a common factor of y. So factor of y times y minus 4. Then y squared plus 10y plus 24 can be factored as y. Think about two factors of 24, positive factors. Multiply to be 24, adds up to be 10. Two, no, there's no such, right? Oh, 4 and 6. Y plus 4 and then y plus 6. Because 4 times 6 is 24, 4 plus 6 is 10. Now looking for common factors in the numerator and in the denominator. We see y minus 4, right, divides to be 1. Y plus 4 divides to be 1. And y, and this y divided by y is 1. So I have 1 over y plus 6. So that means y cannot be negative 6, right? If y is negative 6, negative 6 plus 6 equals 0. 0 in the denominator is illegal in mathematics. So what's the answer for this? The second one. Let's see number 8. We're dividing two rational expressions. Yeah. Again, dividing, we can change it to be multiplication. Then we flip the numerator and denominator. Yeah, but we still have to factor this first rational expression. So let's factor that. X squared minus 1x minus 6 can be factored as x minus 3 times x plus 2. Then the denominator, let's factor out the denominator. X minus 2 times x minus 4. Then multiply by the dividing, I change to be multiplication. Then I flip the numerator and denominator. So x minus 2 now becomes numerator. And x minus 3 now becomes denominator. So again, I'm looking for common factor. So I have in factored form. Multiplication, I can just multiply numerator with the numerator, denominator with the denominator. So the numerator, I have 3 binomials. Denominator, I have 3 binomials. So I'm looking for the common factor. I see x minus 3 in the numerator, x minus 3 in the denominator. Those two becomes 1. Because x minus 3 divides by x minus 3 is 1. Then I see x minus 2 in the numerator, x minus 2 in the numerator, in the denominator, that becomes 1. So I'm left with x plus 2 in the numerator, x minus 4 in the denominator. Okay, so this is the answer you should put in here. 9 is similar. Excuse me. We change this division into multiplication. We flip the numerator and denominator. Okay. Then we see, excuse me. So this second term becomes multiplied by x plus a divided by x plus 3. So dividing that becomes multiplied by its inverse, x plus 3. Then we look for common factors in the numerator and in the denominator. We see, so this term becomes this multiplication. Then multiplication with the multiply numerator with the numerator, denominator with the denominator. So we see x plus 3, this cancelled. But then what do we have? We have x plus a squared divided by 5. So the answer is, because we have x plus a here, we have x plus a here, we have 2 factors of x plus a, x plus a. So the answer is x plus a squared divided by 5. Okay, let's see 10. We want to add those two rational expressions. We need a common denominator. So the second denominator can be factored as x plus 1 times x plus 3, right? Because 1 times 3 is 3. 1x plus 3x give us 4x. So that's the factor of this. So the first expression already have x plus 1. So we need to multiply x plus 3 in the numerator and in the denominator. Basically multiply by 1. And this 1 is x plus 3 divides itself. Okay, multiply by the numerator. Same thing, we multiply by the denominator. Now, the numerator becomes x times x plus 3 plus 2x plus 4. We simplify, we have x squared, then 3x plus 3x plus 2x plus 4. 3x plus 2x, that's 5x. So we get x squared plus 5x plus 4. Oh, do you see that can be factored? That can be factored as x plus 1, x plus 4. Okay, so the numerator becomes this now. So this is the numerator. And denominator is just this, x plus 1. So you will put this one in the denominator. So we see we have x plus 1 over x plus 1. Then the answer should be x plus 4 divided by x plus 3. Okay, since the 11 is right here, let's finish 11 as well. Remember, look at this, we have 4 layers of expressions, right? We want to multiply the common factor c minus 2. So we'll multiply c minus 2 over itself divided by c minus 2. When we multiply by this, we need to distribute. C minus 2 times this 1, that's just c minus 2. Right? Then c minus 2 times 2 divided by c minus 2. You see c minus 2 numerator divides this c minus 2, that becomes 1. So we have plus 2. So by doing so, this 1 becomes c minus 2. And this term multiply c minus 2 becomes just 2. Same thing for the denominator. Denominator, let me use in different color. The denominator is 1 becomes c minus 2 minus 2 over c minus 2 times c minus 2. That's just 2 minus 2. So let's just simplify the numbers. So c minus 2 plus 2, that's just c in the numerator. Denominator, we have c minus 2 again with c minus 4. So that's it. So f divided by c, right? The numerator we're treating as f. The denominator we're treating as c. F divided by c equals to this, c over c minus 4. Your answer for function f of c, well, what's function f of c? So if the numerator is f of c, that's 1, just the numerator. 1 over 2 divided by c minus 2. For g of c is in the denominator, or this is the plus, the numerator is 1 plus. The denominator g, denominator is g, so that's 1 minus 2 over c minus 2. All right, and f of c divided by g of c is this. So I'm going to make more videos for the rest of questions. Hope this helps.